Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today our discussion topic is chapter 10G, that is your definite integral part. Do you know what is integration? What is definite integration? Why we are doing this integration part? Exactly. I know you all know, but if not, then today is the lecture for you. Let's have a look our today's class. So dear students, according to our lesson plan, today we are going to discuss about first the basic of the definite integral, then we'll going for some mathematical problem. So first of all, at the case of basic of the definite integral, we need to understand what actually the definite integral is. We have already known what is the integration, and at the case of integration what thing we need to have understand. Actually all of that are actually same, but at the case of definite integral we will going for some special thing. So what about that? To understand definite integral, we'll first draw a curve. Say for example that is the curve, and this is the curve of f of x. Okay, so if we are thinking that we are trying to find a area in between some limit, that is the definite integral. What is it? Actually at the case of only integral or the integration, actually what we had done, we were just find some area, but here it is definite. That means we'll find the area with the limit. Okay, I am going for a part that is the integration sign, where say for example it is a, it is b, it is f of x dx. Actually what is this, and which thing actually expressed by it? Here it is the lower limit, this is the upper limit, or you can say it inferior limit, this is the supreme limit or superior limit, and most importantly these two represents two line, that is x equal a line and y equal to b line. That means if we are trying to focus on find the area of x equal a and x equal b from this curve, say for example this is the line of x equal a and this is the line of x equal b, then if we are trying to find the area in between these two lines on the or under the curve of it, that is the definite integral. That means definite integral, that is a to b, integration of a to b f of x dx. That means it represents a area. This area must lie between this part, that is this area actually represented by this expression. Clear? Dear students, from this part actually we are trying to focus on to find out this part, but what or which way we can find this area part? It can be found by two ways. One is definitely by the integration, and the another thing by our just manual way, that is or using the geometric part. If we are trying to focus on, or if we are trying to actually find the area of this part using or by finding the or by using the geometrical part, that can be like this. First of all we have to divide this part as much as small you can do. Actually this is not enough, we should have to actually write more closer than it. What I was talking about, the first thing, that we are trying to find out the area of this part by manual way or by geometrical way. Which way? That is, we will just divide all that part as much as small you can do. Okay, maybe I have written here or I am trying to give the line like this way, actually this is not the way. It have to be more smaller. That means the distance of this, if we are thinking that the distance is h, it is actually tends to 0. And the number of line here, maybe we have how many lines we have been used, maybe 10, 20 or 30, but the line must be infinity. So how many lines are there? The line, that is n line, that actually tends to infinity. Okay, so number of lines should be tends to infinity, and the difference of these two line or the corresponding two line is h, which is tends to 0. So you can understand that how much infinitesimal actually part will be separated. Okay, after separation, if we are try to find out the area, so dear students, what I was talking about, that we are trying to focus on the find out the value of a to b f of x dx. It should be actually which way? Here the distance of these two line, actually my line wasn't actually appropriately, and at the same time here should be the number of infinity line should have to be actually given. I can't do, but I was tell you that it's very impossible thing, but we are try to do, or we are try to actually find the area from it. Okay, so what will be that? Actually, if we are closely think about only the first red line and this blue line, it's actually, if we are going for the zoom part, then we'll get like this, isn't it? And here I was tell you that the distance of this blue line to red line was h, and since this is the x equal a line, that means this is f of a. So what's the area of the first exactly rectangle? You are right, f of a into h. So now for the second line, it can be like this after zoom part, or if it is not zoom, or if it is where what we need to do, that is it should be a line, because if we are trying to focus on a curve, which curve will be actually subtracted by the infinite way, that is nothing but a line. And a single line, if we are drawing that line and this line is very much close to each other, that's why the h was actually not equal 0, it was tends to 0. Okay, so our second part, since I have already told you that this is h, that means this is also h, but it was f of a. So what we have to write? It should be f of a plus h into h, because this was h and this should be our f of a plus h. If this part or this system is going on and on and on, then what we can write? Exactly, the second another part should be a plus 2h into h, then the part should be f of a plus 3h into h, and if it is going on and on and on, then when it will be the finishing part, the finishing part should be f of a plus n minus 1 into h into h. So after doing all of that, that means for every rectangle, if we find the area of that and then subtract all the rectangle, then the area we find. But my dear students, after doing all of that, we'll get a great error from our exact value. That's why our scientists actually invented a form, that is the summation, and that summation is the definite summation, so that we can find the area of these types of curve very easily if there is given two limiting values. So that is our that is the thinking behind actually what? Inventing the procedure of the definite integral. Okay, now we will see the system of integration, that means system of the definite integral, how we can solve these types of maths from here. My dear students, we have already learned the integration part. All the things are very much similar, just one thing we need to understand about the what? Limiting value. This is very new to us, but what thing we need to do for the limiting value, I wanted to actually explain now. So I will tell you that it should be a to b. Now I am going for a limiting value, which can be integers, say for example 1 to 5. Okay, 1 to 5, and we are trying to focus on to find out the e to the power x dx. My dear students, you know what is the integration of e to the power x? Exactly, that is e to the power x plus c, isn't it? But since here given the limiting value, that's why we'll use the third bracket, and given here the limiting value, then what thing we will do from here, we will putting this value at the place of x first, that is e to the power 5 plus c, minus, then we'll use this at the place of x, e to the power 1 plus c. That means we'll get e to the power 5 plus c minus e minus c. That means e to the power 5 minus e to the power 1 or e. So my dear students, from here what actually I wanted to tell you, at the case of definite integral we don't write the c. Why we don't write c? Because c will be cancelled, that's the answer. That's why we will not use the c at the definite integral. Okay, so how about that? So when we will we have given e to the power x dx, we will write only e to the power x power 5 to 1, and we will get e to the power 5 minus e to the power 1, that is e. Is this very tough to you? Absolutely not, because we have already known how to integrate. Now we are just putting the value at the case of definite integral. So I think you can understand that what new thing we have to do at the place of definite integral. My dear students, now this is the time for solving some mathematical problem. So dear students, our first mathematical problem is question number 10. Here is given, find the integration of 0 to pi by 4 dx divided by 1 plus sin x. Actually we have to integrate this. How we can go for it? Okay, our solution part. Here is given the integration of 0 to pi by 4 dx, it should be 1 plus sin x, isn't it? So to solve these types of problem, first we will actually multiply by both numerator and denominator with the opposite sign of it. Okay, so if we are going that, then you will get 1 minus sin x, it should be 1 minus sin x divided by 1 plus sin x, then 1 minus sin x dx. Okay, then 1 minus sin x divided by 1 minus sin square x dx. So you all know that 1 minus sin x divided by cos square x. My dear students, 1 minus sin square x cos square x, you know it very clearly, because sin square x plus cos square x equal 1. From that we can write sin square, it should be cos square x. Now we can divide it by which way? So 0 to pi by 4, 1 by cos square x minus sin x by cos square x into dx. Then 0 pi by 4, 1 by cos square is what? Exactly sec square x, and it can be written as 0 pi by 4, actually sin x by cos x, that is tan x, and 1 by cos x, that is what? Sec x. So sec x into tan x dx. Dear students, I think you all can understand that what I wanted to say here, that is sin x by cos x is tan x, and 1 cos x will be left at the denominator, that is 1 by cos x is sin x, sec x. Now sec square x dx, if we integrate it, we will get tan x, and when integration is done we'll going for a third bracket and we'll write this minus, it should be sec x into tan x should be what? Exactly sec x, and it should be pi by 4 and 0. So dear students, what we had to do, have you remembered that? Exactly, the limiting value will be at the place of x. Limiting value, if we put here, then it should be tan pi by 4 minus tan 0 minus sec pi by 4 minus sec 0. So tan pi by 4 is 45 degree and tan 45 is nothing but the 1, and tan 0 obviously it should be 0. And what about sec 45? Cos 45 is 1 by root over 2 and sec 45 must be root over 2 minus sec 0. If cos 0 is 1, sec 0 must be 1. So we'll get 1 minus 0 minus root over 2 plus 1. So finally what we'll write from it? We can write 1, it is 2 minus root over 2. There students, that's our required answer of this integration. I think you all can understand our first mathematical problem. So let's have a look our second problem. So dear students, our last and next mathematical problem is find the integration of 0 to pi by 2 cos cube x dx. How we can solve these types of problem? Dear students, our solution part should be like this way. Here is given what? Here is given this part. So you can write here the given part. Integration of 0 to pi by 2 cos cube x dx. So dear students, to solve these types of problem, we will actually take a help of the formula of 4 cos cube x. Do you know what's the formula of it? 4 cos cube x, which we have been already memorized from chapter 7, that is your trigonometric section. Exactly, the formula is cos thrice x plus 3 cos x. So just to actually putting these values, we need first 4. How we can actually take here the 4? So 4 should be 4 cos cube x dx. Here the limiting value will be there, and since 4 we have taken extra, so we'll just neglect it by 1 by 4. Now 1 by 4, 4 cos cube x is the formula of cos 3x plus 3 cos x. So we'll just input here the formula, that is cos thrice x plus 3 cos x and finally dx. Now 1 by 4, we can separate the integration, that is cos thrice x dx plus 1 by 4 3 cos x dx. My dear students, we all know that we have to just putting the value of the integral value after what? Integration. So if we integrate cos 3x, then what we'll get? We know integration of cos ax is sin ax divided by a plus c. Since this is a definite integral, that's why I will write here 1 by 4 sin thrice x divided by 3 pi by 220 minus plus 1 by 3 into 4, that is 3 by 4 integration of 0 to pi by 2 sin x. So since we have already integrated, so no need to write here the integration part, just writing there the third bracket and putting the limiting value. Okay, so now just putting the limiting value in here. So now here we found 1 by 4, here 3 is here also, so 4 into 3. Then if we just putting the value of pi by 2 in here, then we will get sine 3 into pi by 2 minus sine 0. Okay, then plus 3 by 4 sine pi by 2 minus sine 0. So here we will get actually 1 by 12. Here sine 3 pi by 2. We need to understand here again. Sine 3 into pi by 2, that means where this actually is staying, 3 into pi by 2. So 1 pi by 2, 2 pi by 2, 3 pi by 2. That means this is the position it's situated. We know sine pi by 2 is 1, but since it is not the area of the sine, that's why it should be negative. So the value of sine should be, sine 3 pi by 2 is minus 1, and obviously sine 0 is 0. It is 3 by 4, here 1 minus 0. So we get here minus 1 by 12 plus 3 by 4. So if here we calculate this, what we will find? We will find like this way, that 12 is our LCM. It is minus 1 plus 9. So it should be 8 by 12. So we will get 2 divided by 3. So that's our required answer. My dear students, I think you all can understand the procedure of the mathematics, and that's the end of our today's lecture. Hopefully this lecture is very beneficial for you. Stay home, remain safe, and try to focus on your study. That's it. Thank you.